respiratory quotient or RQ ratio is carbon dioxide produced upon oxygen consumed. In case of carbohydrates, your RQ ratio is 1. Carbohydrates are CnH2O n times. For example, C6H12O6. They are oxygen-rich substances. That means this amount of oxygen, this oxygen is just enough to oxidize the hydrogen present in the carbohydrate molecule. So the only oxygen that is going to be required from outside is going to be the oxygen that is needed to convert this carbon of the carbohydrate into carbon dioxide. So look at this equation. C6H12O6 plus 6 oxygen is going to give you 6 carbon dioxide plus 6 water. So carbon dioxide, so this oxygen was just enough to convert this hydrogen into water, 6H2O. Okay, and the amount of oxygen required, the oxygen consumed externally, 6 oxygen, which is required to convert the 6 carbon into 6 carbon dioxide. So the amount of carbon dioxide produced, 6 upon the oxygen consumed, that is 6. So 6 by 6 is 1. So the RQ ratio in case of carbohydrates is 1. What happens in case of fats? In case of fats, fat is an oxygen poor molecule or oxygen poor substance. So the amount of oxygen that is going to be required externally is going to be more. Thus your RQ ratio is going to be less than 1. What happens when we consume excessive carbohydrates? When we consume excessive carbohydrates, our body converts the excessive carbohydrates into fats. Like we saw, carbohydrates are oxygen-rich substances, fat is oxygen poor substance. So oxygen-rich substance is getting converted into oxygen-poor substance. So oxygen is released, and that oxygen is used for the metabolism or oxidation of fats. Thus, the amount of oxygen that fat is going to require to be consumed from outside is going to decrease. So the oxygen consumption is going to decrease, since some amount of oxygen is being provided by the carbohydrates, right? Therefore, your RQ ratio is going to increase. So basically your RQ ratio is going to tell you what kind of substances are burning in our body, whether it's the carbohydrates or it's the fat that is burning in our body. Now there are some other conditions, like in case of acidosis. In case of acidosis, you wash out the carbon dioxide present. You want to decrease the PCO2. So the carbon dioxide output increases, your carbon dioxide production increases, thus your RQ ratio increases. In case of alkalosis, you want carbon dioxide to be retained in your body. PCO2, you want PCO2 to increase, so carbon dioxide production decreases and your RQ ratio decreases. In case of fever, febrile conditions, your body temperature is more, thus your respiratory rate increases. Since your respiratory rate increases, your carbon dioxide is washed out. The amount of carbon dioxide produced increases, thus your RQ ratio increases. In case of diabetes mellitus, your insulin is, either there is insulin resistance or insulin is absent. So carbohydrates are not burning, your fats are burning. So RQ ratio decreases. But as soon as we administer insulin, your carbohydrates start burning. So as we administer insulin, your RQ ratio is going to start increasing. And in case of starvation, in the initial days, we have your glucose storage, glycogen storage that is used up. Therefore, the RQ ratio remains 1 or remains near about 1, 0.8, 0.9 towards 1. But as the days progress, your glycogen storage decreases and your fat starts burning. Your fat starts getting metabolized, and thus your RQ ratio decreases.